Good morning to everyone. I am Dr. Sumi MS. The name of the course is Satellite Communication and today's lecture topic is Kepler's laws and Newton's laws. On completion, the students will be able to understand the concept of Kepler's laws and also the concept of Newton's laws. Kepler's laws. Satellites orbiting the Earth follow the same laws that govern the motion of the planets around the Sun. As if the planets are revolving around the Sun, we have satellites revolving around the Earth in its orbit. The fundamental properties of orbits are summarized in Johann Kepler's three laws of planetary motion. They are the Kepler's first law, second law and third law. Kepler's laws apply quite generally to any two bodies in space which interact through gravitation. The massive of the two bodies is referred to as the primary object and the other one is the secondary or satellite. So, the primary object will be Earth and the secondary object will be the satellite revolving around the Earth. Kepler's first law. The path followed by a satellite around the primary object will be an ellipse. An ellipse has two focal points F1 and F2 and a semi-major axis A and a semi-minor axis B. The eccentricity of the ellipse is given by the expression E is equal to root of A square minus B square by A. So, in this diagram we have the ellipse with focal points F1 and F2 and semi-major axis and minor axis. So, A is the semi-major axis of the ellipse and B is the semi-minor axis of the ellipse, and the eccentricity value when it lies lesser than 0, when it is lying between 0 to 1, that is greater than 0 and less than 1, then the orbit will be elliptical, whereas when the eccentricity is equal to 0, then the orbit becomes circular. Kepler's second law. Kepler's second law states that for equal time intervals, a satellite will sweep out equal areas in its orbital plane focused at the barycenter. We have to know what a barycenter is. In space, there are two or more objects orbiting each other will be having a center of mass, and the point around which this object's orbit is called as the barycenter of the object. The barycenter is usually closest to the object which is having higher mass. So, as in the given diagram, assuming that the satellite travels distances S1 and S2 meters in 1 second, the areas A1 and A2 covered will be equal, and the average velocity in each case is S1 by 1, that is S1 meter per second and S2 meter per second, and because of the equal area law, the velocity at S2 is lesser than that at S1. So, here we have the ellipse with two areas A1 and A2 swept by the objects, and this will be equal, and the average velocity in each case is S1 and S2 meter per second, and according to the equal area law, the velocity S2 is less than velocity S1. Kepler's third law. Kepler's third law states that the square of the periodic time of orbit is proportional to the cube of the mean distance between the two bodies. So, the mean distance is equal to the semi-major axis A, and therefore, A cube is given as mu by n square, where n is the mean motion of the satellite in radians per second and mu is the Earth's geocentric gravitational constant, whose value is 3.986 into 10 to the power 14 meter cube per second square. Newton's laws. Sir Isaac Newton developed laws of orbital mechanics from which Kepler's laws can be derived. These include Newton's laws of motion as well as Newton's law of universal gravitation. Newton's first law of motion, which is also called as the law of inertia. A body that remains at rest or moving in a straight line at a constant velocity will remain in the same speed unless it is acted upon by a net outside force. So, an object in motion will continue to remain in motion unless it is affected by an external force. And a planet is moving in an ellipse, that is not in a straight line, As per this law, there must be some force acting upon the planet to keep it in motion. If otherwise there is no force, then the planet will fly off in a straight line. Newton's second law of motion. The acceleration of a body is directly proportional to the force acting on it and is inversely proportional to the mass. So here we shall write F is equal to ma, where F is the force, a is the acceleration and m is the mass of the body. Newton's third law, which is also called as the law of reciprocal actions. For every action, there is an equal and opposite reaction. The law can be more fully stated as whenever an object exerts force upon a second object, the second body exerts an equal and opposite force upon the first one. That is, when the sun pulls on a planet with a force of gravity, the planet pulls on the sun with an equal magnitude force. But since the sun is so much more massive than the planet, as per Newton's second law, the sun will experience much less acceleration. Newton's law of universal gravitation. Every object in the universe attracts each other object with a force directed along the line of centers from the two objects. This gravitational force of attraction between these two objects who are having mass m1 and m2 is found to be directly proportional to the product of the masses as well as inversely proportional to the square of the distance between them. So here the gravitational force of attraction F is equal to G m1 m2 by r square, where m1 and m2 are the mass of the two objects and r is the distance between the centers of the two objects and G is the gravitational constant. From this law and laws of motion, Kepler's laws of planetary motion can be derived. Quiz questions on Kepler's laws and Newton's laws. State Kepler's laws of planetary motion. What do you mean by Newton's law of universal gravitation? Define Newton's second law of motion. State law of inertia. Thank you.